I want to show you how to solve logarithmic equations. First, let's remind ourselves of the definition of a logarithm, and that is that if we start off with an exponential equation, b to the power p equals L, then we could rewrite that as a logarithm that keeps the same base, b, but switches the L and the p around. That's going to mean that logarithms and exponentials are inverses of each other. In order to solve the type of equations that we're going to deal with here, we're going to use that definition of the logarithm. For instance, when we have log base 36 of x is equal to 3 halves, we want to rewrite that as an exponential equation first. So we're going to keep the base the same, but switch the other two. So 36 to the 3 halves power is equal to x. Now you remember, with a power of 3 halves, the half is actually a square root, and the 3 is 36 to the 3rd power. So we can take the square root of 36, which is 6, and cube that, which will equal 216. So let's say we have log base 9 of x is equal to 1.5. Now if you're not recognizing, of course, that 1.5 is 3 halves, you could still do the problem. We're going to rewrite it as an exponential equation. So keep the base the same and switch the other two. So 9 to the 1.5 is equal to x. And now you could just use your graphing calculator to do 9 to the 1.5. And you'll get that x is equal to 27. One more like this. Log base 16 of x is equal to 5 halves. So we keep the base the same and switch the other two. So 5 halves equals x. Again, that half means square root. So we're going to take the square root of 16 to the 5th. Square root of 16 is 4. 4 to the 5th is the same as 2 to the 10th. And 2 to the 10th, we all know, is 1024. But how about when we have x as the base, like log base x of 49 is equal to 2? Well, we can still use that definition of the logarithm to rewrite the equation as an exponential. We're going to keep the base the same and switch the other two. So x squared is equal to 49. Now, since x is the base of the exponent, we can get rid of a power using a root. So I'm going to take the square root of both sides, and we get x is equal to plus or minus 7. Now, one thing to point out here is that our solution is not plus or minus 7. If we were to plug that back into our original equation, we could have log base 7 of 49 is equal to 2, which is true. The second one would be log base negative 7 of 49 equals 2. And this is a logarithm that we don't use. We don't use negative bases for a log. Now the reasons for why are a little bit beyond the scope of what we're trying to do here, but it has to fall along the lines of continuity and ambiguity. So our actual solution for this is just going to be x equals 7. All you have to do is know that the base of a logarithm can only be a positive number. If we got log base x of 8 is equal to 3 halves, we rewrite it, keeping the base the same and switching the other two. So x to the 3 halves is equal to 8. Now you might be a little concerned about how can I get rid of that 3 halves power. I don't have a 3 halves root, but we can use powers to help us out. What we want to get is our x to have a power of 1. So I'm going to multiply this to the 2/3 power. So I can use the reciprocal of the power to help get our base to just be x. Because when I go power to a power, we multiply them together. 3 halves times 2/3 is 1. Then for 8 to the 2/3, the third would be the 3rd root, and the 2 is the power. So the cubed root of 8 is 2, and 2 squared is 4. So that's how you solve a very specific kind of logarithmic equation, one that we could just use a definition of logarithms to solve.